mostly staying on this side, right?
Yeah, it probably would be better to have this over here.
I can modify it.
Yes, sir.
Yeah, do you have to go on the, I mean, we can start from the, when we get the Z.
Yeah.
Yeah. And we put the Z on the system.
You could, if you wanted to, start from there, put the Z back into the system and solve with algebra. But at this point, you're only 3 more steps from being done. There's not much point in stopping. Okay? This, when you're talking about matrices, this is called reduced row echelon form, and this is called row echelon form. I know those are big names, right? Okay? And when you get it, getting something into row echelon form, which means that you have numbers across the diagonal, that you have zeros in the corner here, that is a valid methodology of solving. Is to solve for the one variable via matrices and then go back and use algebra to solve for the other two. It's a valid methodology, but it's not typically what we would do in a situation simply because we're so close to being done, right? After all this work that we've already done, we may as well keep going, right? We may as well not stop now, okay? The nice thing about matrices is when you get to bigger systems, okay? When you're talking about a system of 3 unknowns with 3 equations, matrices are somewhat of a lengthier method to solve that, right? Okay, it takes a little bit longer typically because we're not as practiced in it as we are with our basic algebra, right? Though once you get quicker at it, it's just the same, right? But in general, when you get to bigger systems, for example, I was solving a system yesterday when I was working on a problem, and a portion of the problem involved solving a system with 5 unknowns and 5 equations. But when you get to that many unknowns and that many equations, it can be really messy to try to solve it with algebra. Okay, you're going to start losing terms, and things are going to go awry, and then you're going to be like, oh, my answer's not even close because all of a sudden I made a 2 + 2 isn't 12 error, right? So, and it's just because things get messy because it's so big. So my suggestion to you would be to start practicing at this so that when you do get to the higher level maths and you have so many more unknowns, then this can come quite naturally and faster than it would at this point, okay? All right, because the more you do, the faster you get, right? Okay, so this is our practice test here at Larkin. I'm going to let you do my scrolling. Unfortunately, I don't have access to the pretest, so we're going to have to do the practice test. Hopefully by Tuesday, the pretest will be working again and we can finish up with the pretest, okay? But lucky for us, this shouldn't be too different, right?
Tuesday.
Tuesday is the test?
Yeah, we can make it.
We should. I thought your test was on Thursday. Is it Tuesday?
Tuesday.
Okay, well then apparently we're just going to, I did send him an email. So my hope would be that it will be open on Tuesday or before Tuesday. I hope it will be that it will be open today. Okay. We have 2 equations here in our trigonometric form, right? Because we have our numbers. And it's asking us to find u over v. Who remembers this formula? It's R1 over R2.
Theta 1 minus theta 2.
I Yep. Okay. This is our equation. So here we have, this is my R1, right? And this is my R2. Okay. Here's my theta 1. And here's my theta 2. Look how pretty when I can rearrange theta. Okay, so we take R1 over R2, right? So u over v is going to equal 6 over 24. Okay. Cosine of 190 minus 90 plus I sine of 190 minus 90. Simple? I lost it. Okay. 6 over 24 can be reduced. Right? All right, and this is an adequate answer. All right, if we wanted to shorten it back to the form that it started in, this is, then we can do this, right? I forgot what? Oh. Sorry. Oh, and I forgot a 0 there, didn't I? Somehow 190 minus 9 seemed to work for me. Okay? Everybody good with this? Yes, ma'am. If theta was negative, we would have to, again, theta, let's say theta had been negative 100, that would have meant that we were down here. So we would have had to do 360 minus the 100 to get back. Okay? Because it does, I should say the standard here is to use positive angles. Okay. Everybody good? Good. Give me a second. Does anyone see any eraser? Oh. Sorry, I didn't have to use my hands the whole time.
Not too high, you want to bring it down?
What now?
Not too high, you want to bring it down?
Oh, no, we can make it work. All right, we never did the equation for this one, but let's intellectually think about what we're doing here, okay? It says find v cubed, okay? Well, we know what u times v is, right? We need that down here anyways. U times v is equal to what?
R1 times R2.
Right? Okay. So if we're thinking about it from this standpoint, you can check your book and see what the formula looks like in there. But what would we think that v cubed would be? Okay, well basically what we're doing is v times v, right? We're doing this process basically 3 times, right? That's however you want to do that. Okay, so what do we think it might be?
R cubed. And 3 cosine of theta.
Right? Or 3 theta. Okay. Okay. All right. Chances are good. The equation in your book is going to look something like this. V to the n is equal to r to the n cosine of n theta plus I sine of n theta. Yes? Is that what it looks like? Oh, good. Okay. And they're going to use the n's in physical system work no matter what our exponent was, right? Okay. All right, so let's plug in here. We're told that r is 13, right? We have 13 cubed. And theta is 169, so 3 times 169. Sorry, I lost my degree signs again, didn't I? Okay?
Is that 3 times 169 to the third that you put in there with cosine?
This isn't to the third, this is the degree sign. I was trying to put the degree sign back in there.
So what's in the parentheses?
This is 3 times 169.
Okay.
need to write this here down. All right, what is 13 to the third? I don't have it, so now I'll think about it. What is it? 2197. And then we have cosine of what?
147.
One what?
147.
147. I have a feeling that 3 times 169 is not 147. So what did we get?
507.
507?
Yeah.
Oh, okay. I'm like, why is that not an answer choice? All right, so what we really got here was 507 degrees, right? Okay, but again, that's greater than 360. So we want to simplify this, right? So we're going to subtract 360 from it, and we get 147. Everybody good with this? Okay, so plus I sine of 147. Put my degree signs back in there, and in the parentheses. And so this should be our answer. Okay, notice here that they went ahead and put it in the sys form. Okay. Same thing, right?
Look at the bottom.
I'm sorry. I know that was confusing because we started on the next problem. I'm sorry. Everybody good with this? It's not any harder than multiplication, right? All right, same thing here. We have R1 times R2. Oh, I thought I was dividing again. I was doing it incorrectly. Cosine of 480 plus 80 plus I sine of 480 plus 80. Okay. And 27 times 7 is what?
189.
Okay. 480 plus 80 is going to give me what? 560. Okay. That, of course, is greater than 360, so we subtract, and we end up with, oh, that's not a 3, 200 degrees. Okay? So this should give me 200. I guess we don't really need those parentheses now. Have it. Everybody okay with this? Yes, then maybe. Does everyone want to sleep? No? Okay. Okay, it says write z is equal to negative 8. I'm going to do it down here so that I don't have to stretch myself, okay? So we have z is equal to negative 8 minus 7. That was an odd looking 7. I, right? Okay. That's an I. I know it's hard to see it. That's an I. That's right here. That's an I. Okay? And it's asking us to put it in cosine sine form, right? Asking us to put it into the trigonometric form. Okay, so the first thing we want to do again is pretend like this is our x and this is our y, and we're going to use the polar coordinate system, right? Okay, basically, we're going to use the same concept as polar coordinates. So what we know then is that r squared is equal to x squared plus y squared, right? Okay, and we also know that the tangent of theta is equal to y over x, which are the two things that we need in order to solve, right? Because we need r and we need theta. Okay, so let's plug these in here. So we get r squared is equal to negative 8 squared plus negative 7 squared. Okay, so we have 64 plus 49. What do we get? 113. And then r will equal the square root of 113. I don't believe that reduces. All right. And then we're doing the tangent of theta here, right? Tangent of theta is equal to y, negative 7 over x, negative 8. And what do we get? We need to do the inverse, right? Tangent of 7/8. Tangent inverse, right? 21.2 degrees is equal to theta, okay? Now here's the question, is that correct? No, why? Because it's in the third quadrant. Remember I told you guys, since this is x and this is y, we can use that to figure out that over here we're -8 in the x direction, right? -7 in the y direction. So we're down here somewhere, so our angle needs to come all the way down to there, right? So we need to be in the third quadrant. Right now we're up here somewhere, right? And we know that tangent is always 180 degrees from itself, right? So we can take the angle that we got and add 180 degrees to it. We get 221.2. Okay. So putting this in CIS form, now we simply take our R and our theta and put them in. So we have root 113 CIS and 221.2 degrees. Okay, everybody okay with that? And I'm going to assume that 10.63 is the square root of 113. Yes. If you do this on the test, I'm more than happy for you to leave this in its exact format. Okay, even though our answer is unexact because of this already, this being an exact format is perfect. Okay, you don't need to go and find it. That's what it's about. I suppose I would accept either, but exact format. All right, so we have a system of equations here. Did everybody get that? I'm sorry, am I erasing too fast? Okay. All right, we have a system of equations. And these are both, actually they're both ellipses, aren't they? Everybody see that? Yes, no, maybe? Why do you say that? Why do I say that? Well, you know, we haven't gotten into these structures yet, have we? Okay. So I'll show you. When I change this format, it looks similar to a circle, doesn't it? Okay, so we know that it has a circular structure. But what makes it a circle versus an ellipse is the fact that it's stretching basically in the same direction in x and y. Okay, so the format that we typically look at it as this. Okay, this is an ellipse. Okay, the difference between an ellipse and a circle is that these are going to be exactly the same for the circle. Okay, so in the circle, a squared and b squared are equal to each other, in which case we simply multiply by it, and we end up with that over here. Okay, so in this case, let's call a squared and b squared r squared. Okay, and we have x squared plus y squared is equal to r squared. Okay, this is my circle. Okay, and this is an ellipse. And really the only difference is the fact that these are different, okay? When you're doing an ellipse, you're going to graph it almost exactly the same as a circle, right? Except, well, this one would be centered at 0, right? Because we're not shifting, okay? Everybody remember circles? Some of you guys are looking at me like I'm crazy. Do you remember circles from 136? Okay? If there's nothing here, if this is just plain old x, not x minus or plus something, then we're centered at 0, 0, right? Okay? This ellipse is the same way. If we're not subtracting or adding something to the x here inside of the square, sorry, I forgot what square was called momentarily there, then it's centered at 0, 0, okay? So with an ellipse, then what's going to happen is this is going to be A, and this is going to be B. We'll just call this B, okay? And an ellipse is going to look like this, right? Okay. With a circle, the A and B would be exactly the same, so let's now call this A, and let's say it's the same, and then it looks like a circle. Okay, it's the only difference, right? Okay. So in this case, we can tell that it's an ellipse because were we to divide by 36, what's underneath the x and y would be different here and here, right? Okay. Same thing here, were we to divide by the -9, what's under, ooh, actually that is not an ellipse because of the minus sign. I missed that. All right, this actually becomes a hyperbola, which is a minus sign. Okay, but were these both pluses? Same concept there. Okay, a hyperbola is basically just an ellipse that we've broken in the middle and flipped outward. Okay, and that's what the negative sign does there. All right, everybody good with this basic concept though? So what we've got then is an ellipse. Okay. got an ellipse. It's going to look something like that. That's probably about right too, because x is going to be longer than the y. And then we have a hyperbola, and the x is negative, y is positive. I believe it's going to look something like this. Okay, something along these lines. However, we should get 4 points. Okay. Possible. Should be 4 points. So, I have to look, that ellipse might be facing the other direction. Looking at points too. Okay. So, how do you think we would go about solving this?
Sorry, give me all your answers.
I probably would use substitution, but you could use elimination. The reason I would use substitution is because we already have x squared right here. Nicely solved for. But I'm not sure that it really makes that much of a difference. What now?
3y and the negative.
Oh, that's true. That's true. Let's use elimination. That's true. Good point. I like her point. Okay, 3y squared is equal to 36, and then 2x squared minus 3y squared is equal to negative 9. Okay, that's a good point. Elimination gets rid of that immediately, doesn't it? All right, so we can do 3x squared is equal to, I'm sorry, what? 27? Okay, when we divide by the 3, we get that x squared is equal to 9. Okay. And so what do we get here for x? Plus or minus 3. Okay, plus or minus 3. Not just 3. Okay, because we're taking the square root of this, and that means we have plus or minus. Okay, so don't forget that plus or minus. It still exists. We just get rid of it for radii because it doesn't make any sense, right? Okay? So we've got this. Now we need to plug back in for my y, right? We can pick either equations. So let's just do it here. 9 plus 3y squared is equal to 36. Okay? When we subtract the 9, it's looking a little familiar, isn't it? 3y squared is equal to 27. Y squared is equal to 9, and y is equal to minus 3 again. Okay.
How would you like the answer?
The answer should be
I'm like that on the quiz, and I don't have it right here.
the answer should be 4 points. I would have written the answer in point format. They've got theirs x, y, x, y, x, y, x, y. I would have written them as points. So I would have gone 3 and 3, 3 and negative 3, negative 3 and 3, negative 3 and negative 3. Okay? Notice that we're going to have all combinations of that there, right? That's how it's 7. Okay, we're going to have all 4 combinations possible for those values. Make sense? Yeah. Okay. And that is what this one. And I'm naughty today. I think that's right. They're also squished together. I'm having trouble telling.
It's right. It's good.
Yeah.
No.
No. Wait, positive 3, negative. Positive, negative, negative. Yeah, I think that's right. If this is the answer box, we're going to assume that those answers go together. I'm having trouble telling on not which answers go with that dot. But I believe that those answers all go together. So if that is true, then this is the right dot. What now?
The dot centered in the middle of them.
Oh, yeah.
Is it? Okay.
Yeah.
Well, I wasn't sure because they all kind of run together.
Then
So I was concerned that maybe, there's only 3 of them or something like that. But yes. Point format is probably a little cleaner than having all these x's and y's in there, but it's equivalent. All right, ready? Okay. All right. You are trying to construct a bridge over a lake. Okay, so we've got some lake going on here, right? Okay. And we want to put a bridge over it. Points A and B are at the starting and ending points, of the bridge. Okay, so we've got some bridge going across the lake here, point A and point B, right? From your observation point C, okay, so here's you. Here we'll give you some binoculars, just for the sake of it. There, that's binoculars, okay? Not sure what it looks like, but it's binoculars, okay? All right, so this is you and you're at point C, right? I'll just point C right on your tummy. Okay. Point A is 1,000 feet away. All right. And point B is 1,100 feet away. Okay. And then it says the angle ACB is 120 degrees. All right, so what do we need to use? Laws of cosines, right? Because we have two sides with an angle in between the two. Okay, because we're using laws of cosines. So we're looking for this side over here. Why don't we just call it x for the sake of it, okay? All right, so we have that x squared is equal to 1,000 squared plus 1,100 squared minus 2 times 1,000 times 1,100 times the cosine of our angle, which is 120 degrees. Okay? Everybody good with that? All right, I'm just going to plug and chug here, and x squared is equal to 1. This will not be on the no calculator portion. At least not with numbers that large. However, you do need to know what 14 squared is. For those of you who forgot from the last one. 196 is x squared? No. Oh, that's not the answer to the question. I'm sorry. I was like, that's not possible. Yes, 196. I said that because last test on the no calculator portion, 14 squared was on, I think, the blue color, and a bunch of people missed 14 squared. Like, they knew how to do all the trigonometry, but they missed 14 squared, and I was like, So, I was teasing, that's all. All right. Did you plug it in?
No.
That big mess? Anybody else plug it in? What now? After we already put the square root? 1,819 feet. Oops. No, it's not right. 0.34 feet. Anybody else get the same thing? We have confirmation of this answer? Yes. Yes? Good. Okay. So x here, that's our length, is this. And I'm looking at this going, they're not the right answer. I know. What did we do wrong? Okay, that's this right here, right? Everybody good with this?
Just a quick question. When you do cosine of 120, that would be, what, negative 0.5?
That's negative. Okay. So what's going to happen here is that negative plus this negative means that you're going to end up adding this to this.
Oh, okay.
Okay, which makes it more positive than it was over here, which is exactly what we needed because this is the largest side.
Okay.
Make sense?
Yep.
Okay. So we actually don't want to subtract that. So it works out quite nicely that it fixes that for us, right? That smart guy that came up with this formula. Whoever it was. I guess I should know that math history, shouldn't I? Who wrote the law of sine? I actually don't know that. Okay. So they want us to take this and put it into our a plus bi form, right? Okay. So again, for our case, we're going to go ahead and say x plus yi, okay? And we're going to use polar coordinates, right? So what we know, again, is that x is equal to r cosine of theta, right? Good. Somebody knew that. And y is equal to r sine of theta, right? We already knew this, didn't we? We already knew this because this is from our unit circle, isn't it? And our unit circle R is 1. Right? Everybody good with this?
Yeah.
Okay. All right, so we're going to just replace R and theta here with what we know that they're equal to, 5 and 650. We could go ahead and make that smaller if we desire. 290. We can make that 290 instead of having to deal with 650 if we want. Okay, same angle. Buster, why are you looking at it like that? You can't see. Okay. All right, so x is equal to 5 times the cosine of 290 degrees. And y is equal to 5 times the sine of 290 degrees. Okay, and what do we get here? What now?
X is 1.7.
X equals 1.71. And y is equal to?
4.7 minus negative 4.7.
Okay, so we need to go ahead and plug that back in here, right? So what we get is that z is equal to 1.71 plus, or let's go ahead and just do minus here, minus 4.7 I. And as usual, it's the same.
I didn't know where you would land, so I just.
It's okay. Everybody good with this? Simple, right? This is easy? Okay? You need to know Poland's coordinates anyways for the next test, so we may as well get comfortable with them now. Okay. Find the magnitude of vector v. How do we find the magnitude? What is it? The length of the vector, right? Okay, it's basically the distance. So if we've got some vector v here, okay, call this vector v, okay, and we've got the x value, basically what we're saying is that this is 7, right? Oh, it's going to negative, I'm sorry. Let's redraw vector v. Sorry about that, okay? So this is 7, right? And this here is negative 10, okay? And what we're really looking for then is how long the distance of this vector, right? So we're using the same thing as our distance equation, okay? Everybody remember? Distance is equal to the square root of x squared plus y squared, right? Okay, same thing we did with circles and everything else. Same thing as where the Pythagorean identity comes from, all of it, okay? It's all related, okay? In this case, we're going to change this just slightly, and we're going to change this to vector v and put lovely little magnitude signs on there, okay? And instead of x and y, we're going to put I and j, okay? Same thing, I'm just changing a few little letters there, right? So, the magnitude of vector v is equal to 49 plus 100. Okay? So the square root of 149, is that reduced? I don't see it. I think that is the answer. Yeah. Everybody good with it? I know, doesn't it? But it is that easy. It is. Don't make it harder than it needs to be. Okay. All right, in a triangle, we have A, alpha, B, and C. So we've got some triangle, and we'll call this alpha, and we'll call this beta, and we'll call this gamma. So that means this is going to be A, and this is going to be B, and this is going to be C. All right, we were given alpha at 40 degrees, right? We were given B was 50, whatever units, and C is 15, whatever units. Okay, we need to find the rest of the triangle. What should we do? Laws of science?
Laws
Laws of cosine. We can't use laws of science here because we don't have a side opposite an angle, right? Okay, we have to have an angle and a side that are opposite of each other to use laws of sine, and we don't. Anytime you have an angle embedded in between two sides, and that's all that you have, we have to use cosine. Right? What two times do we use cosine? An angle in between two sides, and what else? All three circles. Okay. I guess I could use side, angle, side, right? Okay, so we need to find a first, right? That's what laws of cosine is going to give us. So we have a squared is equal to 50 squared plus 15 squared minus 250 times 15 times the cosine of 40 degrees. All right, and who wants to tell me what a is equal to?
Wait,
A squared is 2,000?
Yeah, A squared is
2,000 what?
2,600.
2,610. All right, is that even? 0.9.
Well,
0.1.
yeah.
So A would be equal to, what'd you get?
1,500.
Let's find out.
Oh, yeah, that's right.
Make a mistake. Yeah, I got it. Know what you guys got? Becomes 39.76. Okay, so A is equal to 39.7 units, whatever they happen to be. Now what should we do? Now we should use law of sines, right? Okay, because now we have an angle with a side opposite of it, okay? So let me erase my vectors. So we end up with the sine of 40 over 39.7 is equal to the sine of beta over 50. All right, so of course we end up with 50 sine of 40 over 39.7, and then we're going to do the inverse sine of that is equal to beta. So what did we get for beta? 54.1. 54.1. Okay. Well, we should have solved for gamma first. Why should I have solved for gamma first? Because it's the smallest side, okay? And it would have showed me that most likely this is actually wrong. We need the larger angle, okay? So what is this? Minus 180. 180 minus 125.
Yeah. Why not?
Okay. So most likely this is 125.9. Let's solve for gamma with laws of sines. We should have done gamma first. Okay, everybody see why? Okay, I always pick, and I didn't today, but when I'm doing this on my own, I always pick the smallest side first because that's going to direct me to the larger side if possible. Okay, so we have the sine of gamma over, 15 is equal to the sine of 40 over 39.7. So gamma will equal the sine inverse of 15 sine of 40. All right, what do we get for gamma? 14.1. Okay. And you can see that 14.1 plus 40 gives me my 54.1, so it definitely is the 25 point. Everybody good with that? Okay. So beta here is 125.9 degrees, and gamma here is 14.1 degrees. Okay. Do be careful about that. Do be careful. If you had used 25 degrees here, you should have been able to look at it and intuitively know that it didn't make sense. Right? Okay? 25 degrees is smaller than 40, and yet B is bigger than A. Okay, everybody see that? It wouldn't have made sense. We needed this to be the smallest angle because that's our smallest side. Okay? So make sure you check yourself on that because it would be easy to say, oh, okay, great, this is the right answer, and move on. Okay, so just be careful and check yourself and make sure that you are cautiously looking for things like that in your circle. Okay? All right. All right, so we have a triangular plot of land with three sides, 300, 700, and 800. And we want to find the angles. Let's call that gamma, we'll call that beta, and we'll call that alpha. Okay? And they want us to find the angles between the sides. What do I need to do? Cosines, right? Okay? I can't find it with sines because I don't have an angle opposite a side already. All right, so let's just randomly pick which angle we're solving for. Which one? Alpha. Okay. And solve for alpha. Okay. We know that alpha and beta are both what? Acute, right? We know that they're both acute because gamma, in this case, in our convention, must be our largest side, right? Okay. So given that fact, solving for alpha and beta first makes sense so that we don't end up with, the wrong angle and have to switch, right? So we have that 700 squared is equal to 800 squared plus 300 squared minus 2, 800, 300 cosine of alpha, right? I forgot which angle momentarily we were solving for. Okay, so what is this? 64, 640,000, is that right? Anyone?
Yes.
I'm sorry. Okay, 90,000 minus 100 cosine of alpha equals one more. There we go. Curtis, can you not see it? Okay, so we're going to take this and subtract these two, right? And get some negative number. What is it? Okay, I can type with that. Okay, when we divide by the negative 48,
Cosine of alpha is 1
cosine of alpha is
equals 1 half.
how pretty that is. Okay, where is the cosine equal to 1/2? 60 degrees, good. Or 5 degrees. Okay, so the alpha is equal to 60 degrees. I'm okay with using degrees. All right, so we have alpha now. Now what should we do? Laws of sines. Okay. So the sine of 60 over 700 is equal to the sine of, and we're going to do beta first, okay, because we know that gamma is probably obtuse. If not, it's the largest angle for sure. Okay, so we're going to do beta first. Actually, it may not be obtuse in this case, but
Alpha and beta will be gamma.
yes. Okay. And so we have 300. The only reason we didn't in the last one was because I wanted to prove that our gamma, our beta was the large one. I think it's beta. Okay. So solving for this, I have that the sine inverse of 300 sine of 60 over 700 is equal to beta. Oh, we could do most of this without a calculator. What do we get? What's beta, guys?
Which one was mine?
21.8. Okay. And then in order to find gamma, we're just going to say 180 minus 21.8 minus 60 is equal to gamma, which is what?
98.2.
What is it?
98.2.
98.2. All right. It was indeed slightly obtuse. Okay. So this one. All right, so we have another triangle. We have an alpha, a beta, and a, oh, yep, that's right, an alpha, a beta, and a c. So we'll call this alpha, and we'll call this beta, and we'll call this gamma, and we'll call this c. Okay? So c is equal to 33, alpha is equal to 80, beta is equal to 35. All right, what's the first thing that we should do? Find gamma. Right? That's the easy thing. So we have 180 minus 80 minus 35 is equal to 100 minus 35, which is 65. Okay, and there's gamma. What? Oh, we can stop now? We'll just stop. Marcia wants to stop. Okay. Well, I know, but on your test, you're not going to have these options. So you need to pretend like you don't when you're taking the practice test or the pre-test, right? Pretend like you don't have. Good, that makes the test look good. Have faith. Okay, so what are we going to use here? Laws of sine, exactly. Okay, so we have the sine of 80 degrees over A is equal to the sine of 65 degrees over 30 degrees. Right? Rearranging this, I get 33 sine of 80 degrees over the sine of 65 degrees is equal to A. Right? And what do we get there for A? I have got this whole stuff in my head. Not sure how my own way. 35.9. Okay. And we can use Pythagorean theorem to solve for B, right? It was a trick question.
Okay.
No, why can't we use Pythagorean theorem? Because it's not a right triangle, right?
Oh, yeah,
Okay, all right. I gotcha. It's like Simon says, right? Okay, let's do it again. The sine of 65 over 33 is equal to the sine of 35. Sorry, I lost my angle there for a minute. Over B. Okay, so we end up with B equals 33. Yes, sine of 35 degrees over sine of 65 degrees. And what is B? What now?
20.9.
20.9. All right, and again, we're going to look at this and we're going to check it and we're going to see if it makes any sense. Okay? Is my largest side across from my largest angle? Yes, okay? Is my smallest side across from my smallest angle? Okay? The chances are good we're right. Okay, we might have made some calculation error, minorly, but it looks pretty good. Everybody good with this? Good. Okay. I'm going to speed up a little bit because we're running out of time. All right, find the unit vector in the direction of this. Remember, to find a unit vector, the unit vector is equal to v over the magnitude of v, right? Okay, so we take the magnitude of v, and it's equal to the square root of 9 plus 36, which is the square root of 45. Okay, and then we're simply going to take the vector v. I'm sorry. This reduces, and I just can't help but fix it. Okay. So we're going to take the vector v. Okay. This is unit vector v, and we're going to, I'm going to do that for unit vector v. All right, we're going to cancel the 3, so we have 1 over root 5I minus 2 over root 5j. Okay? Is that right?
Anyway, but yeah, just use the root of 5. I mean, you can rationalize it.
Oh, it can be rationalized. Of course it can. Of course it can. Root 5 over 5 minus 2 root 5 over 5. And I'm the first one to take off for that too, aren't I? Okay? Everybody go with that? That's what I get for being in a hurry, right, Ash? I got a copy. I'll leave that there for a second. Okay, suppose that we have blah, 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 and we're looking for a minus b, right? I know, that was excellent math right there. Okay, let's go ahead and change a into a vector. Okay, and let's change b into a vector, because they're easier to work with like that than those awesome English. A minus b is simply going to be the subtraction of the 2, right? Okay. And the most important thing here is that we do what? Keep the sign straight, but we go in the same order, right? Okay? If we do this minus this, then we better do this minus this. Okay? If we want to go the other way around, is it really going to change our answer? It's really not. Okay? It's really not. B minus A should be pretty much equivalent to A minus B. The only difference is that our magnitude of the vector would be different, right? Okay? It may be a negative of the vector, but we're going to, for the purpose of where you're going with this, okay, it won't matter in the long run, right? Because it's not going to be obvious. When you start using A minus B in terms of vector notation in calculus, it's not going to be obvious which one you should be subtracting. You're just going to know you have to subtract them, okay? And it won't matter which ones you subtract from each other. All right, in this case, because it specifically tells you, yes, it would make a difference, right? Because it will indeed change the magnitude of the vector. But for where you're going with it, it won't matter as long as you do it in the same order, okay? It's kind of like slope, right? Kind of like when we do slope. Okay, so A minus B is equal to what? This is plus, so negative 7. This is minus. And there we go. They put it back in INJ notation. They probably left it in INJ notation. Okay. Next. Okay, we're finding 10a plus 11b. What does multiplying a scalar do? It just stretches it out, right? And all I'm going to do is multiply it by each part, okay? So what I have here is that a is equal to negative 3, negative 7, and b is equal to negative 9, 10, right? I'm multiplying a by 10 because I want this to be 10a. So that just simply becomes times 10 and times 10, right? We want that to be 11b, so times 11 and times 11. Make sense? So a is equal to negative 30, negative 70, and b is equal to negative 99 and 110. Okay? And then we're simply going to add the two vectors together, which means we add the x components and add the y components, right? So 10A plus 11B will be equal to negative 129 and 40. What now? Okay. Everybody good? Okay, the angles of elevation of a balloon from 2 points A and B on the level graph. So here we've got some balloon, okay? And we've got 2 points here on the ground. And good heavens, they're giving it to us in degrees in a minute. Of course they are. Will somebody change that for me really quick? Divided by 16, change it to the. And this one would be 41.3. Thank you. Okay, and they are 8.8 miles apart. Okay? And the balloon that is in the air between the points in the same vertical plane. Oh, okay. Find the height of the balloon above the ground to the nearest 10. Okay, well, we will change our tail to a straight line. How's that? We're looking for this, right? Okay. How would we go about this? Let's use law of sine, right? We already have two angles. So we can solve for this entire angle, which is what? Somebody do that real quick. 22.3 plus 41.3. 116.4. Thank you. Okay. So that large angle there is 116.4 degrees, right? So we can use law of sines to find either this or this side. Which one would you prefer? It won't matter. Which one? This side here going between A and the balloon and B? Yeah. Sure. Okay. All right. So what we know then is that the sine of 22.3 over B is equal to the sine of 116.4 over 8.8. Everybody good with that? Okay. And we can go ahead and rearrange, of course. And we get 8.8 sine of 22.3 over the sine of 116.4 is equal to B. And what do we get for B? What?
Yeah, that's all I'm looking at that.
3.7?
No, that's not right.
I think 3.7 is closer. 116 is
It's
our
gotta be the
largest.
big.
116 is our largest angle, so 8 is going to be our largest side.
Oh, the big side.
Okay, so it is 3.7?
Oh, okay.
Okay. I'm waiting for confirmation here. Somebody else who got the same answer, right? Okay, so we got 3.73 for B. Now how do we find H? Why can't we use Pythagorean theorem? Because the 8.8 is this whole thing. We don't know what this is, right? It's not halfway between them. I promise. Okay? The reason it's not halfway between them is because these are not equal. Okay? If these were equal, then based on theorems of isosceles triangles, we would know that the altitude was precisely halfway between the two. Because they're not, we cannot assume that. In fact, we're certain that it's not true. Okay? This is going to be shifted towards this angle because it's small. Okay? So we have to use laws of sines again, only now we have this angle here across from this side, right? We're doing a different triangle. And this angle here across from our height. Everybody see that? I got some knots. Okay. So the sine of 90, which is what? 1. Thank you. Took you guys a minute. Oh, that's 1. Okay. So we basically end up with 1 over this, right? So the height is equal to 3.73 times the sine of 41.3. 2 point what? Height is equal to 2.5 miles, I suppose. It's all miles, right? Okay. So we have 2.5. Okay. All right, how many more did we have?
32.
32 more?
There's a total of 32.
Oh.
Should be, that's practical.
That was 24.
24.
Okay.
Okay, so we didn't lose too much here. So if you are confused about any more of these that we did not get to, please text me. Okay? Hopefully we got to the majority of the concepts. I think we did. I feel like we did. But if you're confused about anything that's further on the exam, please text me your questions and I will be sure to answer them. Make sure that when you text me, you either write the problem in the text or you take a picture of it, and don't just say number 5, because I don't have it memorized, okay? And it'll make our lives a
Come on
lot
now.
easier if I don't have to wait until I can get to a computer to find the problem. Okay? I know, what's wrong with me, right? Why don't I have it memorized? No. Solving systems of equations is on